Hi students, welcome to physics class. Today we are going to discuss about uniform circular motion. Once again, uniform circular motion. Once again, my dear students, listen carefully. Today we are going to discuss about uniform circular motion. Now take a circle. Now take a circle. Here take the center. This is the center. Its name is say C. From the center, draw a radius. The radius name is say R dash. Now draw another radius. Draw another radius. Its radius name is R. Consider this is the angle. Now draw a line which is touching the 2 points, that is P1, P dash and P. Now draw a tangent here. Draw a tangent. The tangent is V dash. The tangent is V dash. Now draw another tangent here. Here the tangent is V. Now consider this point is P dash. Consider this point is P. Now take consider this is delta theta. Delta theta means small angle. This one is nothing but delta R. Once again, from P to P dash is nothing but delta R. The time from here to here is nothing but delta small t. The time taken to reach from P to P dash is delta t. Now take here the same diagram. It is extend like this. Therefore, this is V dash. Now take this one extend like this. That means draw a parallel to V. This is parallel to V. Therefore, it is the center C. It is the center C. It is velocity V. This vector is parallel to this V, and this V dash parallel to this V dash. Now consider this is delta theta. Therefore, this is delta theta. Now the difference between these two is delta V. Now what is delta V? Delta V is nothing but V dash minus V. What is delta V? Delta V is V dash minus V. Remember, according to this is, now take this is delta theta. This is velocity v1 vector. This is velocity v vector. Now this one is delta v. From a triangle of vector, from triangle log of vector this is C. V vector plus delta V vector is equal V dash. V vector plus delta V vector. See the direction. Delta V vector is equal V dash. Therefore V vector plus delta V vector is equal V dash. Therefore V vector V dash vector minus V is equal delta V. Now take a circle here. Take a point P. The acceleration is towards the center. This is point C, center. That this is the radius. The radius vector is outward direction. And the velocity is perpendicular direction. This is velocity direction. Once again, I am repeating. This is radius. This is acceleration. This is velocity. That means radius vector always opposite to the acceleration vector, and these both are perpendicular to the velocity. These are the important points we have to remember. Now we are going to elaborate about the content of uniform circular motion. Now see, when an object follows a circular path at a constant speed, at a constant speed, comma, the motion of the object is called is called uniform circular motion. Uniform circular motion. Once again I am repeating, when an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. Now since the velocity of the velocity of the object is changing continuously. In direction, comma, the object undergoes the object undergoes acceleration. The object undergoes acceleration. Once again I am repeating this point or this paragraph. Pay attention. Since the velocity of the object is changing continuously in direction, the object undergoes acceleration. Now our aim is to find the magnitude and the direction of acceleration. Once again I am repeating this paragraph. Our aim is to find the magnitude and the direction of acceleration. Now let small r and r dash be the position vector and v dash be the velocities of of velocities of the object, velocities of the object when it is at P and P dash. Once again I am repeating this point. Let small r and small r dash be the position vector and velocity v and velocity v dash be the, let smaller and smaller dash be the position vector or radius of a circle and v dash be the velocities or velocity vectors of the object when it is at P, at point P and point P dash. Since since the velocity since the velocity is tangent since the velocity is tangent in the direction of in the direction of in the direction of motion of object, motion of object. Once again I am repeating, since the velocity is tangent in the direction of motion of object. Once again I am repeating, since the velocity is tangent in the direction of motion of object, since the path is circular, since the path is circular, comma, velocity v is perpendicular to r, perpendicular to r. Once again, since the path is circular, velocity v is perpendicular to r and v dash is perpendicular to r dash. Since delta v is perpendicular to delta r. Once again, since delta V is perpendicular to delta R. Therefore, the acceleration along delta V direction. Once again, since delta V is perpendicular to delta R, therefore the acceleration along delta V direction means the acceleration the acceleration is perpendicular to is perpendicular to delta R. Once again, this is very important point. I am repeating, listen carefully. Since delta V is perpendicular to delta R, therefore the acceleration along delta V direction means the acceleration is perpendicular to delta R. That means A is equal delta V whole by delta T. Consider equation number 1. Therefore, the magnitude of A is given by that is mod A is equal to limit delta tends to 0, limit delta T tends to 0, limit delta T tends to 0, delta V magnitude whole by delta T. Consider this is equation number 2. Once again I am repeating this point. The magnitude of A is given by magnitude of A, nothing but delta A, is equal to limit delta T tends to 0, magnitude of delta velocity by delta T. Consider equation number 2. Now let the angle between position vector small r and r dash be delta theta. Once again, let the angle between position vector r and r dash be delta theta. Since the velocity vectors, since the velocity since the velocity vectors v and v dash are always perpendicular to the position vectors Once again I am repeating this point. Since the velocity vectors v and v dash are always perpendicular to the position vectors, therefore the angle between them the angle between them is also delta theta. Since C, P, P dash and G, H, I are similar. See my dear students, once again I am draw the diagram. This is C. Consider this is point P dash, this is point P. Now this is a tangent, nothing but velocity v. This is a tangent, nothing but velocity v dash. Here take a straight line. This is v. Now the angle is delta theta. Now this is delta r. Consider this is small r, this is r dash. Now take this is C. I am taking the similar triangle. Say G, V dash. This V dash is parallel to this one and this V is parallel to G, N. It is I. This is the direction. The direction is in this direction. Therefore, the direction is from G to I. Similarly, V. Therefore, the direction is from G to N. This is V. Consider this is delta V or V dash minus V. Now, since C P P dash C P P dash and G H I are similar. Therefore, the ratio of the ratio of the base length the ratio of the base length to side length for one of the triangle is equal to that of the other triangle. Therefore, once again I am repeating this point, the ratio of the base length to side length for one of the triangle is equal to that of the other triangle. Therefore, the magnitude of delta V by V is equal to the magnitude of delta R by small r. Consider this is equation number 3. Therefore, delta V is equal to delta R by small r magnitude into V. Consider equation number 4. Once again, delta V is equal to magnitude of delta R by R into V. Equation number 4. Now, equation 4 in 2. Once again I am repeating equation number 4 in 2. Therefore, the magnitude of acceleration is equal to limit delta t tends to 0 into delta r whole by r into v into 1 by delta t, that is equal limit delta t tends to 0 v by small r into delta r by delta t. This is magnitude. Therefore, may I write V by R into limit delta t downs to 0 delta R magnitude whole by delta t, that is equal V by R into what is limit delta t turns to 0 delta R by delta t, the rate of change of position or the rate of change of displacement gives velocity. The reason is limit delta t downs to 0 delta R by delta t is equal to velocity. Therefore, the centripetal acceleration AC is equal to V by small r into V. That is equal, the centripetal acceleration AC is equal V into V, V square by R. Consider equation number 5. Now, that means the acceleration of an object, the acceleration of an object moving with speed V in a circular of radius r, radius small r has a magnitude V square by R and is always directed towards the center. This is why the acceleration is called centripetal acceleration. Centripetal acceleration. Once again, I am repeating this content. AC is equal to V square by R. AC is equal to V square by R. Consider equation number 5. That means the acceleration of an object moving with speed V in a circular of radius small r has a magnitude V square by R and is always directed towards the center. This is why the acceleration is called centripetal acceleration. My dear students, consider it is a point C. Now, it is a radius small r. It is the radius R1. Now, it is a point P dash. It is a point P. Here the tangent velocity is V in this direction. Here the tangent velocity is V dash in this direction. Now, I extend V dash back. At the same time, I forwarded V vector in this direction. Now, here, if it is 90 degrees, because radius and here is 90, it is also 90. It is also 90, it is also 90 because radius is perpendicular to the velocity. Now, it is delta t, 90, 90. Obviously, the remaining one is 180 minus delta t. 180 minus delta theta. Now, here, if it is 180 minus theta, obviously, this is also 180 minus theta. Now, it is delta theta, it is also delta theta. If it is delta, since these two are parallel, if it is delta theta, obviously it is also delta theta. Similarly, it is delta theta, it is also delta theta because corresponding angles. Now, this is V vector in upward direction. Similarly, it is V vector upward direction. Since it is V vector forward direction, therefore the parallel line is V vector. This is also forward direction. Now, this is delta V. According to triangle of vector, we know that delta V is equal to V dash minus V. What is that one? Delta V is equal to V dash minus V. This is the heart of the whole circular acceleration diagram. I hope you understood this video. Now, I hope you understood this video. Thank you very much for watching this video. This is 90 degrees. Similarly, this is 90 degrees. This one is V dash vector. This is V vector. This also V vector. This is V dash vector. And this is delta V. This is delta theta. Since if it is delta theta, it is also delta theta because corresponding angles. I hope you understood this video. Thank you very much for watching this video. The conclusion of the whole is the centripetal acceleration AC is equal to V square by R. This is the derivation we derived. Thank you very much for watching this video.